Coach Fred here, and today I'm going to be talking generally about SAT prep. And I think it's really important, if you've been watching my videos, to when we look at questions and answers, we have to kind of have a plan if we are really not sure what to do. So anytime I look at a math question, I actually have to really remember what math is, okay? Math is the study of patterns. Yeah, I know if I asked you what math is, you're going to tell me, oh, it's about numbers, it's multiplication, it's division. It really is noticing, visualizing, generalizing patterns. So I always want you to ask yourself, if you get stuck on any question, you're not sure of an approach, what do you notice? Now, that could be as easy as the numbers are even, or I notice subtraction. But look at the question. If they give you an equation, look at that. Do you notice it's an equation versus an expression? Do you notice it's an expression versus a function? Do you notice from the answers that the answers are very specific? Are the answers whole numbers? Could this be a place that you plug answers in? So today what we're going to do is we're going to talk about what we notice, and then also the idea of substitution. Substitution on the SAT, if you can master the concept, it's a game changer. And I know all of you really want to take this test one time. You want anything that I call a game changer to be in your repertoire of skill. So let's talk substitution. Okay, so I like to think of substitution anytime a question asks me for variables other than X and Y. Now, it's not always going to mean I'm going to use substitution, but it could be like my go-to. Let me try this, okay? But especially when I ask for like questions that say, what is the value of A? What is the value of B? What is the value of C? Or what is the value of K? These questions I've noticed a pattern to. There's that pattern. I've noticed a pattern that a lot of times you have to use substitution. So I pay attention to that. I want to okay, I'm not really sure what to do here. What should I do? All right. So I want you to look at questions especially carefully, especially when they tell you an unknown variable that's in the question is a constant. Remember, a constant is an unchanging value, so it is a number. That's all it is. So if they put a variable of an A, but they tell you A is a constant, you actually have to think of A like it's a number, not a variable. It's not a changing value. All right, let's look at some examples, and let's talk about what we notice and how we might use substitution. All right, here's a question. It says, in the xy plane, the point 3, 6 lies on the graph of the function f of x equals 3x squared minus bx plus 12. What is the value of b? Okay, so remember, there's that question, what is the value of b? So I ask myself, okay, can I use substitution? So I look at this carefully and I notice that I do have something I can substitute. I have a coordinate point. Remember, a coordinate point is an xy coordinate point with x being the inputs and y being the outputs. So I see an x in my question here and here, well, and even here, but I don't see the y. So I have to look carefully and remember that f of x is just another name for y. So this question really could be written like this. Okay, so I want to take now my 3 and my 6, plug them in for x and y, and solve for b, okay? All right, so let's do that. Y is 6. Anytime I plug something in, I'm going to put it in parentheses, especially if it's squared or if there's a minus. Minus b times 3 plus 12. Okay, I'm going to simplify that. So 6, oh, I switched to blue, that's not going to work. So 6 equals 3 times 9 minus 3b plus 12. Okay, some more simplification here. So 27 minus 3b plus 12 equals 6. All right, I'm going to combine the 27 and the 12, and that's going to give me what, 39? 39 minus 3b equals 6. I'm going to subtract 39, and I'm going to get, here, let me come up here. Negative 33 equals negative 3b. Okay, so I'm looking for the value of b that's going to make that equation true. Some of you are jumping to do the algebra, but I can see that the answer b would have to be 11 because negative 3 times 11 would give me 33. But sure, you could divide both sides by negative 3. Okay, so b would be 11. So I hope you see how I use substitution there, but I noticed that I had a question that had in essence, 3 variables. It had a y, it had an x, and it had a b. So you're going to always have to use substitution in these cases, but the question itself is a pattern I've noticed. All right, here's another one. It says, if a squared plus b squared equals z and ab equals y, which of the following is equivalent to 4z plus 8y? Well, first of all, I've got so many variables here that I'm confused. So what else do I notice? Well, I notice that all of the answers are squares of binomials. That's important because remember, a square of a binomial came from a perfect square trinomial. So I noticed that. Now, if you forgot what a perfect square trinomial is, it's really good. Go back to my perfect square trinomial video because that's an important factor pattern for us. And the relationship between the perfect square trinomial, or the PST, and its factored form, the square of a binomial, is really helpful on this test. All right, so what I decided to do was to use some substitution because there were so many variables. So instead of z, I'm going to take a squared plus b squared, and I'm going to plug it in for z, because all my answers also have a and b in it. All right, so that's going to give me 4 times a squared plus b squared. Okay? All right, plus, then I'm going to plug in 8ab for y, so plus 8ab. All right, so then I'm going to distribute my 4, and I get 4a squared plus 4b squared plus 8ab. Okay, so since my answers were squares of binomials, I need to make this look like a perfect square trinomial. So a perfect square trinomial needs to be in standard form. That means descending order by exponent into rising order by the second variable. So I would have to write this as 4a squared plus 8ab plus 4b squared. Remember, in algebra 2, you learned that as your a's go down in exponent, your b's go up. So really, there is a b here. It's b to the 0, right? And here, there is an a here. It's just a to the 0 because that's the number 1. So it's there. It's just hidden. So that would give me standard form, and then I can put it in factored form. It's a perfect square trinomial, so I know my result's going to be the square of a binomial. The pattern to perfect square trinomials, to factor them, would be take the square root of the first term, so 2a, okay, and take the square root of the last term, which would be 2b, and take the sign of the middle term. So my answer would be B. All right, so that was a little bit more. You had to notice, you had to substitute, and then you had to know some algebra. All right, let's look at the last one. It says, in this equation above, k is a constant. What is the value of k? K is a constant, so that means a number, right? We talked about looking carefully at that, and that's a hint that I might be using substitution. What is the value of k? Another hint that maybe I'm going to use substitution. So what can I substitute? Well, I know that x is 9, so I'm going to plug in 9. So the square root of k plus 2 minus 9 equals 0. All right, well, I'm going to bring the 9 to the other side because I feel like I can do more with this equation, okay? Now, absolutely could use algebra here, but all of my answers are whole numbers. And we've talked a lot about what the word equals means. So if all my answers are whole numbers, I have a very simple equation that the algebra might get a little, I could make a mistake with. I might just plug in the answers and make them equal, meaning, remember, equal means is the same as. Is the same as. So I might do that. So, look, if I plug in 1 plus 2, that gives me the square root of 3. The square root of 3 is not 9, okay? The square root of 3 is smaller than 9, so it's not 1. If I plug in 7 plus 2, I get the square root of 9. The square root of 9 does not equal 9, so that's not it. If I plug in 16 plus 2, that gives me the square root of 18. The square root of 18 does not equal 9. 79, I get 81. I get the square root of 81, which is 9, so my answer is D. So it's just a quick, easy way for you to check yourself. Now, could you do the algebra? Yes, you'd have to square both sides, and you get k plus 2 equals 81, you'd subtract 2, and you get 79, and you should always verify when you square an equation, you should verify that your answer makes a true equation. So either way, it's fine. I just want to show you that plugging in the answers is also a really good way to solve problems. All right, guys, I hope that video was helpful. Remember, if you're unsure what to do, look at everything you can, the questions and the answers, to see what you notice, okay? All right, have a great day.